using tips. So if we look at the results, we have the fitness agent which answered the request which we sent. So it was the fitness agent that first took out the request. So from the result, we have the full body workout routine which it actually generated. So which is what we have below. And we asked for two things. We said, can you provide me full body workout routine and stress reducing tips? So after it was done, the wellness agent took over from him. So then from the wellness results, we can see these are wellness tips and which is based on the question that we asked. Hello, welcome back to my YouTube channel. So in today's video, I'm going to show you how you can build a multi-agent supervisor system using LangGraph, Qwen, and Streamlit. So we're going to demonstrate by building an AI health assistant by using the supervisor multi-agent architecture. So this AI health assistant will comprise a team of specialized experts. So where we'll have the fitness agents, we'll also have the mental health agents, and we also have the dietitian agents. So all these three different agents are going to be working together to improve the user's fitness, nutrition, and mental health. So to build these agents, we can look at the diagram. So we have the user, we have the supervisor, and we have these three different agents which actually route back to the supervisor. So I'm going to explain the work of the supervisor. So what the supervisor does is just like it actually coordinates all the tasks. When I mean by coordination, is just like the supervisor actually assign each of the tasks to the agent. We can explain the work of the supervisor is just like the manager that controls everything that is going on between the agents, whereby it assigns the tasks and it also monitors the progress of those tasks execution. So for our large language model, we're going to be using Qwen. So where we pull the Qwen 2.514b, so which is what I put here, I'm going to be using Olama to pull it. So in case if you have no idea on how you can set Olama up in your machine, there's actually a video which I already created. I've attached the link above. So for our agents, we're going to be creating a custom tool. So each of the custom tool we're going to be creating for these agents are going to be connected to an external API. So for instance, the dietitian agent, we're going to be using the Spinacular API, which will actually allow us to generate meal plan, get recipe information. And for the fitness agents, we're going to be using the API Ninjas, so where we get workout routine and other information from there. So, and the requirement.txt, these are the things that we actually need to install on our machine. So now that I've explained everything about the AI health assistant which we want to build, so now let's go to our code. So this is our code, and which is the Jupyter notebook file which we want to use. But first and foremost, we need to create a .env file. So this .env file will have all the API keys which you want to use for this project. So if you go to your browser, the API Ninja's official website, go to the profile page. So here you can click on show API key. So when you get that, you can copy it and you bring it down to exercise API key. So anything you copy from them, so just paste it here. While the Spinacular API, so just come to the profile page as well. So you create your account, come to the profile page and click on generate or show API key, and you can get the API key. So I'm going to attach all these links to the description. So we're going to import our library. And we're also going to bring in the API keys, which is for the fitness and the diet API key. So in building our agent, so the first and foremost is we need to define a state. State is very important because it actually helps us to keep track of all the conversation as the agent move across the workflow. So, and if you notice, we use the message states. This message state is actually from LangGraph. So we're going to be using the message state from LangGraph, which already knows how to store a list of messages. We're going to be narrating the behavior of these message states, so which is what we actually pass into our own states, which is the class which we want to create. And we had additional string, which is next. But now let me run this code. So the next thing is we need to define our tools, and So before we create our tool, we actually need to get data from each of those API. So the first one is the fitness API, where we're using the API ninjas to get all those different exercises. So if you look at this class, we define the base URL, which is the endpoint to the API ninjas exercises. Then we pass in our API key. So from the first function, you can see get module group and types. This is where I actually get the data from the API, and this is where I generate a workout plan. So by calling all those different functions and how I actually want the output to look like. So after I've done that, I have all those functions and everything in this particular class. Now I want to create the fitness data tool. To create this tool, you can see that we created a function. So this is a fitness data tool function, and we also pass in a query. So the query is anything that the user sent. And if you notice what I have here, which is like a doc string. So this doc string is a description for this particular tool, because if you are creating a custom tool in LangChain, you ensure to pass in a description. So when the agent is trying to pick up any tool, it's use the description to understand, like, okay, this is what this tool is doing. And we also call in we call the class by creating an object of the class, and we call the generate workout plan, so which is this particular function here, where we actually generating a workout plan for the user. So and okay, so after we've done that, we also put at tool decorator. So when you're creating a custom tool in LangChain, you ensure to always put that at tool decorator, so which actually converts it to a custom tool. So after we've created our custom tool, so let me call the class to show you an idea of what the data looks like. So I'm going to say fitness data, then let's do fitness. So, and we say fitness dot generate workout plan. So let's see what it looks like. So let me pass in let's say full body. So I need to run this particular code. Yeah, so this is actually what the result is going to look like. So you can see how I actually tailor the results. So how I want the result to look like. So I have exercise 1, so module instruction, exercise 2, so that's just how the data looks like. So, and whenever the agent calls this tool, so this is the actual result which we're going to be seeing. The next tool we need to create is the dietitian tool. And before we create the tool, we actually need to get the data from the API. We can see the base URL, the API key from here. So, and we're using the meal planner generate endpoints, and we also using the recipe information endpoint. So each of these endpoints is where we get all the meal plans and the recipe information from them. So this function fetch the meal plan, while this function fetch the recipe information. So while here I call both function, and I also clean up the results coming from there. So I create what I actually want to see. So information such as meal, prep time, ingredients, instruction, something like that. So this is what I did here by actually creating a meal plan. So let's run that particular class. So if you see here, we're also creating the tool, so which is for the diet tool. And I'm going to call the class. So let's create an object of that class so we see what the data also looks like. So let's call this diet. So and say diet dot. So that's generate meal plan. So we actually need to pass in a query here. So the meal plan that we need to generate can either be for vegetarian, vegan, or let's say the general meal type. So here, let me say vegetarian. Yeah, so this is how the output is going to look like. So anytime the agents use this particular tool, so this is what the agent is going to return. So you can see the type of meal. We have the meal, we have the ingredients, we have the instruction. So I created something like 3 different types of meal, and where we have all the daily nutrients from it. So you can see the daily nutrients below. So now that we've created the different tools that we need, which is the fitness and the diet tool, so we're going to define our large language model which we want to use. So find the model and we pass in the memory here as well, so we can run that. So the next thing is the agent. This is where we actually create the agents. Our first agent is the fitness agent. So the first thing here, we define the agent prompts, and we're using the pre-built create react agents. We pass in the large language model, and we pass in the tool which we want the agent to use, so which was the custom tool that we defined earlier. We also pass in the prompt here. If you look at this fitness node, so this fitness node is just like what we are going to pass into our graph. The fitness agent that we defined, we're using the invoke method, which is the anything coming from the states. So, and then we are returning the results. So this result is, we can see the command. So this command is just like it's just like an object that tells the graph what to do next. So if you can see, go to supervisor, it's just like when this task is done, it should go back to the supervisor. And the results, we are also saying like update the result, which is the last item from the result here. So we just like, we're saying like you should update the state with this particular message. So that is all for the fitness node. So, and the next thing is we also create the dietitian agent. So just the same thing we did for the fitness agents. So we define the system prompt, we also create the react agents, and we also create the dietitian node, so which is the task that it needs to carry out. So where we pass in the dietitian agent, we also use the command object to tell it what to do and how to assign the results. So after we are done with that, we also created the mental health agent. So this mental health agent is just using the large language model alone. We are not using any tools. So what is going on here is just like we are creating like a prompt template where we tell the large language model what to do. So if you see here, we pass in the prompt, then also you see we are using the same command. So this same command tells us like any information that is given, which is from the result from the large language model, we should update it back to the state. And when the node is done, it goes back to the supervisor. So which is that for the mental health agents. So now we also need to create the supervisor agents, which is the main coordinator of everything that is going on in the workflow. So under the supervisor agents, we first defined, the members of the, of the team. So we let it know like we have the fitness, dietitian, and wellness. So we also define something like an options. So here is where we have the system prompt, which is what the supervisor is going to use. And we define this particular class. So the reason why this class was created is just like a way we want the particular results coming from the supervisor to be tailored. So if we look at this supervisor node, it has all information on how it's going to coordinate everything that is going in the workflow. So from here, we put in the message. So whereby we pass in the state message, we also pass in his role and, and the system prompt. So under this response, if you notice what I have under this response, I said LLM with structured output. So where we're using this router. So the response that will be coming from the supervisor node is just going to look like this. Where we have next, so it's just telling us like the next agent that needs to run a particular task. So the results, we either have maybe something like dietitian, it might be fitness, or it might be wellness. So then we also use the, just like we define the go-to thing, so we use the finish, so whereby when it's done with the task, it ends the whole execution. So let's run this particular cell. So there are some cells that I haven't run yet, so I need to go back and run them. So let's run these. So that head tool is not defined. So there's a particular, okay, this is not run. So let's run this back. So let's run this. The next thing is that we need to build a graph. So we pass in the supervisor and we connect each of the nodes. So I'm going to run this cell. And let's see what the diagram looks like. Okay, so we can see everything that is going on inside this graph. So we see the supervisor and each of the agents are connected to the supervisor. So the next thing is we're going to call the agents, for which we expect the supervisor to take up anything that we send and give out the task to any of the agents. So let's do that. So this is just like an helper function, to handle the output. Let's give it a test whereby we pass in, give me wellness tip for the month. Let me run this cell. So if you look at these results, this particular cell is still running. We can see like the supervisor, we can see this next thing. It actually assigned the task to the wellness. So, and the wellness, we can see the results coming from here, which is tips, information about wellness tips and the likes. So I'm going to interrupt this particular cell. So I'm going to show you how I implemented this with Streamlit so we can see how it actually looks at the front-end user interface. So for our Streamlit demonstration, every code that we have under this particular Jupyter notebook, so I kind of put them into different files. So we notice under the agent, so I put everything related to React agents and all those nodes, they are inside this particular agents.py. And the tools, which is the code for all the tools, they're inside this particular file. So utilities is also here. So it's just the same thing that we have inside the previous Jupyter notebook. So I just put them in different file. Let's run main.py. So this is how the interface looks like, which is expecting me to send in some user inputs, whereby the task is going to be run by any of the agents that we created. So I would say, can you provide me full body workout routine and stress reducing tips? So if we look at the results, we have the fitness agent which answered the request which we sent. So it was the fitness agent that first took out the request. So from the result, we have the full body workout routine which it actually generated. So which is what we have below. And we asked for two things. We said, can you provide me full body workout routine and stress reducing tips? So after it was done, the wellness agent took over from him. So then from the wellness results, we can see these are wellness tips and, which is based on the question that we asked. So we can go further to ask more questions. So just like I said, the supervisor is the one coordinating everything. If I ask something related to maybe wellness, supervisor will send it to the wellness expert. So, and if it's anything related to diet, send it to the dietitian. So for my next question, I will say I'm a vegetarian. Can you give me a customized plan? So we look at the results, the dietitian agent actually took up this task. So just like how we define the tool for the, the diet tool. So we see the results, it actually match up with what we actually define in our tool. So we have the meal, meal one, and we have the ingredients, which is what we use to prepare the meals, then the instruction, different meal types, meal two, meal three, and we also have the daily nutrients. So it's also asking us more question by saying I can provide you customized workout plan, asking more other question. This is same thing with what it actually generated earlier. So it's just like when it's done with the other tasks, it moves to the next one and it moves to the next one. So it's just like if I happen to ask something about, okay, can you give me something related to both workouts, both routine like meals and wellness tips. So it's going to generate those three things. So this is a good example on how you can build your own multi-agent supervisor system. If you have any question, please drop them below. Also, don't forget to give me a thumbs up and subscribe to my channel so you can see related videos like this. Thanks for watching. I would love to see you next time.